Good morning. Today we are starting our discussion on a new topic called as Nyquist stability criteria, and this is coming under fourth unit of our syllabus, where we'll be focusing towards the definition for Nyquist stability criteria and some related problems, how to implement this or use this Nyquist stability criteria to comment about the stability for a given transfer function. So let us start with the basic mathematical preliminaries for this Nyquist stability. We know that you will be provided with the transfer function. Let us say it may be an open loop system or a closed loop system. Either it is going to be G of S or you will have it like C of S by R of S. You can comment about stability from its open loop transfer function as well as closed loop transfer function. This Nyquist stability criteria, what it normally does, it tries to map the points from a S plane to a G of S H of S plane. Before getting inside the actual discussion, we will start with the preliminaries, some terminologies related to Nyquist stability criteria, which has to be discussed in a brief way, so that you can understand the concept behind what is how the system is being analyzed based on Nyquist stability criteria. Let us say you have an S plane. We know already an S plane is a complex plane. We can say that S is a complex plane. S is a complex variable which is normally represented as sigma plus or minus j omega. So this any point in this plane can be mapped to another plane which is having a function which is we call it as f of s plane, and it is also a complex plane. To verify or analyze the system in a better way, it's sometimes it is mandatory to map the functions from one plane to the other plane, or one domain to the other domain. If you want to change it from domains and all, you go for transforms. Here it is been mapped from one plane to the other plane. Let us say from S plane to F of S plane. Normally it will be from S plane to G of S H of S plane, because we already know that how do you comment about stability? The stability is commented about based on the characteristic equation. What is the characteristic equation? We say 1 plus G of S H of S is equal to 0. So 1 plus G of S H of S is equal to 0 is how they normally comment, actually. Normally consider for analyzing the stability. From this given equation only, we normally comment about the stability. How do you comment it? If the roots of this particular equation lies on the left hand side of the S plane, then you say system is stable. If all the poles and zeros are lying on the left hand side of the S plane, then you say the system is stable. And if any of the pole lies on the right hand side of the S plane, the roots, if any of these roots available here, most particularly lies on the right hand side of the S plane, then you say the system is unstable. And this is already been discussed in the classroom when you are dealing with introduced to stability, that is based on your router stability. We have started discussing, and we introduced you about asymptotic stability, relative stability, and all in the previous classes. So here we focus towards Nyquist alone. So from this equation, what I can suggest is I will get a G of S H of S. Okay, I will get a G of S H of S is equal to what? Let us say G of S H of S is equal to, I will get G of S H of S is equal to minus 1. This 1 goes to the other side. So based on this I can write this -1 as -1 plus j0 in a complex format because I'm going to represent the values in the complex plane. So I'm converting this -1 into a complex number, -1 plus j0. So based on this particular value, the Nyquist stability criteria will be defined. We will see about that in the coming times. So before getting inside the definitions and all, we will be introduced to two most important terminologies. One is called as encirclement and enclosement. What is called as encirclement and enclosement? Because we are so worried about the roots in the right hand side of the S plane alone. Because if you say you take an S plane, this part is let us say this particular part is a stable part, stable region, LHS, right hand, left hand side, and this area is an unstable providing area. So the right hand side, RHS, this is an S plane. Let us say this is an S plane, an XY plot, S plane, an XY plot. We say left hand side is always a stable region, and right hand side is providing unstable. So we are worried about this, the poles in this particular region. So if you take a closed contour, that is considering all the points, if you say this is your S-plane, I am so worried about the entire region. The radius of this enclosement is infinity. That is the entire right hand side is considered. Okay, this is what they called as enclosed. We say this the entire right hand side region is enclosed. Okay, you can see that from this example. We have 2 points here. We have 2 points here. We are trying to explain you what is the difference between encirclement and enclosement. Both are very important in the definition of Nyquist criteria. Nyquist criteria. So what is an enclosement? You can see that you have 2 points A and B here. A point is said to be encircled by a closed path if it is found inside the path, to the right side of the path. We say this A is being enclosed. You can see it here. Okay, this has been enclosed actually, and it is also encircled. To the right side of this traveling path, okay, if any point lies inside the traveling path, you call it as encirclement, and if a closed path covers a point, you call it as an enclosement. Very simple. That is, this is the traveling path in this direction. That is, we say it is in clockwise direction. To the right side of the traveling path, if any point lies inside the closed path, then you say it is been encircled. It is been encircled. To the right side of the path, if the point lies inside the path, you say it is an encirclement. And also, if any closed path covers a point, then you can say it is enclosed by the covered region. So here we can say, you can see here, this A is being encircled as well as it is enclosed. The A point is encircled as well as it is enclosed. But here you can see in figure 3 what they normally say, the shaded region in figure 2 and 3 are the regions enclosed by the closed path. You can see it here. Both are in clockwise direction. So the shaded region in figure 2 as well as in 3 are the regions enclosed by the closed path. Where reference figure 2, the point A is enclosed by the closed path and point B is not enclosed. Then what is encirclement? A point is said to be encircled by a closed path if it is found inside the path. That is what I am explaining you. Okay, if you are saying it is inside the path, a point is inside the path, then you say it is encircled actually. Okay, a region is found inside the closed path, then you call then you say it is again enclosed. So the point A is enclosed in figure 2 as well as it is encircled, but here this point B is not encircled, but it is enclosed because it is there in the shaded region. You can see, and A is not enclosed here because it is not in the shaded region. The reference to figure 3, the point A is not enclosed by the closed path, but point B is enclosed. You understand, I think. Based on the shaded region, they are saying in this figure, A is being enclosed as well as encircled where B is not enclosed. And in third figure, you can say A is not enclosed, but it is encircled where B is enclosed because it is there in the shaded region. So these two uh, terminologies are very important. What is enclosement and what is called as encirclement? I think you understand the concept. Okay, right. Let us expand it. So we say if you take a closed contour in the S plane, let us say this is S plane and this is f of S plane. You can see it here. It is S plane. This is F of S plane. They have now converging into the definition of Nyquist. So closely watch. Let us say we have two zeros, Z1 and Z2, which is being enclosed by this closed path. Okay, enclosed in S plane. S plane la rendu zeros irukku, Z1 Z2, 1 plus J2 1, 1 minus J2 1, rendu complex conjugate, two complex conjugate zeros are there. This can be mapped, these points can be mapped in a F of S plane, and if you travel along this closed contour, if you draw a Nyquist based on the frequency response similar to that of polar plot, the extension of polar plot is what we call it as Nyquist actually. Based on that polar plot only we'll, we'll further proceed in designing or drawing any Nyquist contour there. So if two zeros are enclosed in this region, that is in S plane, if you map those in your F of S plane, there should be, if it is zeros, the encirclement around the origin. Origin, you know what is 0, 0. Encirclement around the origin should be equal to the number of zeros. For example, here it is two zeros, so you'll see two encirclements. This is one and this is second. So two encirclements in clockwise direction. If it is zero, then the closed contour should be, the encirclement should be there in clockwise direction. If it is a pole, then it should be in anti-clockwise direction. The encirclement should be in anti-clockwise direction. That too, encirclement should be around the origin. Okay. For understanding, we will start with this example. Let us prolong to the second one. We say two poles are there, and this is your enclosement in S plane. Then you see it in F of S plane. You see two encirclements in anti-clockwise direction. Then only you can say it is stable. So two poles, so two encirclements in F of S plane in anti-clockwise. Now you can see two poles and a zero. Two poles and a zero, S minus 2, S minus 4 and S minus 1. So two poles and a zero. This is the enclosed region. Now if you map it, so number of poles minus number of zeros, and if the poles number is more, then the encirclement direction will be in anti-clockwise. If the zeros number is more, then the encirclement direction will be in clockwise direction. Now you can see it here. Two poles are there, one zero is there. So the poles number is more, so the encirclement should be in anti-clockwise. 1 0 is alone there. So 2 minus 1, that is two poles, that is P is 2 and Z is equal to 1. So number of encirclements N is equal to P minus Z, which is equal to 1. and the encirclement will be based on which is higher. Poles is higher, so it is in anti-clockwise direction around the origin. Let us go to the next example. You can see two zeros and a pole. Two zeros are there and one pole is there. So again use the same formula. N is equal to P minus Z, where P is the number of poles and number of zeros. So number of poles is 1, number of zeros is 2. So the difference between, I think I can say you should have a difference here, not minus actually. Find the difference, because people will say, get panicked when if you get a minus 1 here. So they will ask me like that. What happens if minus 1 comes there? Not like that. So it's a difference actually. So number of zeros is 2 and the difference of 2 and 1. Let us say 2 zeros and 1 pole. So it is again 1. And the zeros are more. So the encirclement will be in clockwise direction. Encirclement will be in clockwise direction. Like you see, equal number of poles and zeros are there. So using this, what you will get, Z is Z difference P. So both 2 difference 2 will give me 0. So you will not have an encirclement around the origin. You will not have an encirclement around the origin. Let us say you are not enclosing the poles and zeros here. Again, it results in the same of the previous result. That is, there is no encirclement around the origin. இந்த ரெண்டு கேஸ்லயும் பாத்தீங்கன்னா ரெண்டு போல் இருக்கு, ரெண்டு ஜீரோ இருக்கு. அதனால இந்த என்சர்க்கிள்மெண்ட் இருக்கக்கூடாது. ஏன்னா இது 2 டிஃபரன்ஸ் 2 எவ்வளவு வருது? 0 தான். அப்ப என்சர்க்கிள்மெண்ட் இருக்காது. என்சர்க்கிள்மெண்ட் என்ன இருக்கு? தள்ளி இருக்கு. ஆரிஜின் அவுட்டி இல்ல, ஆரிஜின் சுத்தி இல்ல. இங்கேயும் அதே மாதிரி தான், என்க்ளோஸ் பண்ணவே கிடையாது போல்ஸ் அண்ட் ஜீரோஸ் ரைட் ஹேண்ட் சைட்ல இருக்கக்கூடியதுல. அப்போ அதே மாதிரி என்ன செய்யக்கூடாது? யூ ஷுட் நாட் ஹேவ் an encirclement. So these two cases. ஸோ இது வந்து ஜென்ரலா எஸ் பிளேனுக்கும் எஃப் ஆஃப் எஸ் பிளேனுக்கும் உள்ள மேப்பிங்கை வச்சு ஸ்டெபிலிட்டி அவங்க சொல்லக்கூடிய விஷயம். Now, if you go really for the definition for Nyquist stability, you can see it here. இதுதான் அவங்களோட ஸ்டெபிலிட்டிக்கு நம்ம எடுத்துக்கூடிய கேரக்டரிஸ்டிக் ஈக்குவேஷன் 1 plus g of s h of s. So இதை வச்சு தான் நம்ம என்ன பண்ணோம்? We will be talking about not the origin. We should talk about the point -1 plus j0. இதுக்கு முன்னாடி நம்ம பார்த்தது என்சர்க்கிள்மெண்ட் என்க்ளோஸ்மெண்ட் வந்து உங்களுக்கு இன்ட்ரோடியூஸ் பண்றதுக்காக. Okay. Now we will be getting inside what is Nyquist stability criteria, and the point we are so concerned about is -1 plus j0, not the origin 0,0. Okay, so where it lies actually, -1 plus j0. This is -1, j0 is, this is the point in the left hand side. So your encirclement should be around this point, -1 plus j0 point, not the origin. Origin சுத்தி இருக்க கூடாது. It should not be here. It should be here, -1 plus j0, because the stability condition says g of s h of s is equal to -1. That is the stability condition. Okay, அப்போ -1 plus j0 பாயிண்ட் வச்சு தான் நம்ம டெஃபினிஷன் இருக்கும். We can see that here. Okay, this is the definition. If g of s h of s contour in the g of s h of plane corresponding to the Nyquist contour in the s plane encircles the point -1 plus j0 in the anti-clockwise direction as many times as the number of right half s plane poles of the g of s h of s, then the closed loop system is stable. I will explain you in a simple way. You have two planes. One is s plane and the other one is g of s h of s plane. Now let us say you are considering, let us say I will try to draw, this is an s plane, and let us say this is your g of s h of s plane. This is g of s h of s, and this is s plane. Let us say you have two poles in the right half side, and if you are taking entire right hand side, you are enclosing entire right hand side, so you are enclosing two poles in the right hand side. So what is the definition of this? Nyquist says, since you are enclosing two poles in the right hand side, you should have at least two encirclements. You should have two encirclements, that two encirclements, that two in around the point -1 plus j0, -1 plus j0 in anti-clockwise direction. Because if poles, then the direction should be, encirclement direction should be in anti-clockwise. Even though your system has two poles in the right hand side, in general we say if you have poles in the right hand side, system is unstable. But what Nyquist stability criteria says, even if you have two poles in the right hand side and you enclose the entire right hand side, if you map the points from S plane to G of S, H of S plane, and if you find this, the points which is being mapped is encircling the -1 plus j0 point in anti-clockwise direction twice, because two poles, so twice, then you say the system is stable. The system is stable. Two poles, two encirclements around -1 plus j0, that too in anti-clockwise direction. The system is stable. Okay, that is what the Nyquist stability criteria says. How many number of encirclements should be equal to number of enclosed poles or zeros. We see that here they are given it in a described way. No encirclement of -1 plus j0 point. This implies that system is stable if there is no poles in G of H of S plane. If you say the entire right hand side plane is being enclosed, மொத்தமா நம்ம கன்சிடர் பண்ணிட்டோம் ரைட் ஹேண்ட் சைட் பிளேனை, உள்ள போல்ஸே இல்ல அப்படின்னா கண்டிப்பா G of S H of S பிளேன்ல என்ன செஞ்சிருக்க கூடாது, -1 plus j0 பாயிண்ட் என்சர்க்கிள் பண்ணிருக்க கூடாது. அதான் இங்க சொல்லிருக்கு. That is what it is being mentioned. There is no encirclement in -1 plus j0 point in the G of S H of S plane if there is no poles in the right hand side of the S plane. If there is no poles in the right hand side of the S plane, there should be no encirclement. Okay, right. The second one, anti-clockwise encirclement. Anti-clockwise encircle ஆயிருக்கு -1 plus j0 பாயிண்ட்ல. அப்பனா என்ன அர்த்தம்? அதுக்கு எத்தனை தடவை என்சர்க்கிள் ஆயிருக்கோ, how much time it is been encircled in right hand in the -1 plus j0 point, how much time it is encircled in anti-clockwise direction, then there should be the same amount of poles in the right hand side of the S plane in your S plane. G of S H of S plane la -1 plus j0 point எத்தனை தடவை right anti-clockwise direction encircle பண்ணிருக்கோ அத்தனை போல்ஸ் எங்க இருக்கணும், S planeல ரைட் ஹேண்ட் சைடுல இருக்கணும். அதை என்க்ளோஸ் பண்ணிருக்கணும். அப்பதான் ஸ்டேபிள், இல்லைன்னா அன்ஸ்டேபிள். கிளாக்வைஸ்ல என்சர்க்கிள்மெண்ட் இருக்கு. In this case, system is always unstable. Also, in this case, if no poles in the G of S job is right hand side of this plane, the number of clockwise encirclement is equal to number of poles of the closed. So that is again zeros வச்சு சொல்லலாம். பட் Nyquist வச்சு பெர்ஃபெக்ட்டா சொல்லும்போது clockwise encirclement இருக்கு அப்படின்னா in the case system is always unstable. If no poles of G of S H of S plane in the right of S, if no poles of G of S H of S right hand S plane, then the number of clockwise encirclement is equal to number of poles of closed loop system on right hand. அப்போ எத்தனை தடவை clockwise encirclement இருக்கோ அத்தனை closed loop poles right of S plane ல இருக்குன்னு the explanation says. So very simple. The explanation says that the encirclement is around -1 plus g0 in G of S H of S plane, and that should be equal to the number of poles that to the encirclement should be in anti-clockwise direction. Then it should be equal to the right half of the S plane number of poles in S plane. Then only you can say the closed loop system is stable. Illa appadina closed loop system unstable. Even open loop system stable இருந்தா கூட சில சமயம் closed loop system unstable ஆகலாம். அன்ஸ்டேபிளா இருக்க ஓப்பன் லூப் சிஸ்டம் சில சமயம் க்ளோஸ் லூப்ல ஸ்டேபிளா கூட இருக்கலாம். ஸோ இது முதல்ல மேப் பண்றதுக்கு நமக்கு தெரியணும் ஃபண்டமெண்டலா. ஸோ So we will try to go for how to map it first. இதுல நம்ம ரைட் ஹேண்ட் சைட் பிளேன் இப்படி தான் நம்ம என்க்ளோஸ் பண்ணுவோம். You can see it here, here. இப்போ ரைட் ஹேண்ட் சைடு கம்ப்ளீட்டா நம்ம கன்சிடர் பண்ணிருக்கோம். அதனால தான் ரேடியஸ் ஆஃப் தி என்க்ளோஸ் வந்து பாத்தீங்கன்னா இன்ஃபினிட்டி இருக்கு. அப்படின்னா ஃபுல் RHS நம்ம என்ன பண்ணிருக்கோம், கன்சிடர் பண்ணிருக்கோம் எல்லா கம்ப்ளீட். ஏன்னா ரைட் ஹேண்ட் சைட்ல இருக்கக்கூடிய போல்ஸ்னால தானே உங்களுக்கு இஷ்யூஸ் வருது. அப்போ என்டையர் ரைட் ஹேண்ட் சைடையும் நம்ம என்ன செய்யணும், யூ ஹேவ் டு கன்சிடர். இப்போ அதுல இந்த இமேஜினரி பாயிண்ட்ல இமேஜினரி ஆக்சிஸ்ல இருக்கக்கூடிய போல்ஸை மட்டும் நம்ம என்ன செய்வோம், யூ வில் டேக் அ டீடூர். நம்ம கவர் பண்ணோம்னா அதுக்கு பேர் கான்டூர், அது கவர் பண்ணாம எடுத்தோம்னா அதுக்கு பேர் டீடூர். இப்போ இந்த பாயிண்ட் நம்ம கவர் பண்ணல. ஏன் அப்படின்னா இது வந்து அனலிட்டிக் ஃபங்க்ஷனா இருக்காது. ஓகே, ஸோ அது இன்னொரு கிளாஸ்ல நம்ம டிஸ்கிரைப் பண்ணுவோம் அனலிட்டிக்னா என்ன. நம்ம இப்போதைக்கு செய்ய வேண்டியது எப்படி ஞாபகம் வச்சுக்கணும், we should not consider the points in the imaginary axis. Imaginary axis ல இருக்கக்கூடிய பாயிண்ட்ஸ் நம்ம கான்டோர் எடுக்கும்போது கன்சிடர் பண்ணக்கூடாது. we take a detour around it. You can see it here, you have a pole in the origin, so we are taking a detour. Imaginary axis ல லையா இருக்கு, அதனால we are taking a detour. Third figure ல பாருங்க, you can see it here, these are the points in the imaginary axis. அப்ப அத நம்ம கன்சிடர் பண்ணாம நம்ம we have to take a detour and we have to take contour for the entire right of the S-plane, right hand of the S-plane. Without these points, இந்த பாயிண்ட்ஸ் இல்லாம நம்ம எடுத்துக்கணும். இப்போ ஒவ்வொரு பாயிண்ட்டையும் நம்ம ஒவ்வொரு செஷனா பிரிக்கணும். ஃபார் எக்ஸாம்பிள் இப்போ இங்க you can see it here, இப்போ செஷன் பாருங்க. ஓகே, இப்போ எப்படி how to investigate the stability using Nyquist criteria, that too how to draw closed mapping எப்படி பண்றது, from S-plane to G of S of S-plane எப்படி மேப் பண்றதுக்கு அப்படி பாத்தீங்கன்னா first step is you have to choose a Nyquist contour similar to that of these three figures. In the three figures ல இருக்க மாதிரி depending upon the transfer function you have to choose the entire contour of the right hand side of the S-plane. அதுல சிங்குலர் பாயிண்ட்ஸ் மட்டும் அனலிட்டிக்கா இருக்கக்கூடிய அந்த இட்ஸ் நாட் அனலிட்டிக் பாயிண்ட் அப்படிங்கிற அந்த சிங்குலர் பாயிண்ட்ஸை மட்டும் நம்ம விட்டுருவோம். அதுதான் இந்த டீடோர்னு நான் சொல்லியிருக்கேன் ஏற்கனவே. இந்த பாயிண்ட்ஸ் இந்த இமேஜினரி ஆக்சிஸ் நம்ம வந்து என்ன செஞ்சிருவோம், கன்சிடர் பண்ணாம விட்டுறணும். அது மாதிரி நம்ம இந்த கான்டோரை நம்ம வரையணும். அப்போ நம்ம லெட்டஸ் சே இந்த எக்ஸாம்பிள் வச்சு நம்ம ஃபர்ஸ்ட் ஸ்டார்ட் பண்ணலாம். அப்போ இதுல எத்தனை செஷன்ஸ் இருக்கு, C1 ஒன்னு இருக்கு, C2 ஒன்னு இருக்கு, C3 ஒன்னு இருக்கு. இதுல எத்தனை இருக்கு, இதுல C1, இதுல C2, C3 and C4. இப்போ இதுல எடுத்துக்கிட்டீங்கன்னா you will have C1, this is C2, C3, C4, C5, C6, C7. It goes on. It depends upon how you normally divide it. Second point என்ன, இப்போ இந்த மாதிரி படம் கான்டோர் வரைஞ்சிட்டோம். செகண்ட் ப்ரொசீஜர் என்ன, the Nyquist contour should be mapped. இப்போ இதுல இருக்கக்கூடிய பாயிண்ட்ஸ் நம்ம G of S H of S பிளேனுக்கு மேப் பண்ணணும். Then we have to find the encirclement around -1 plus J0. Okay, இப்போ let us say example, the Nyquist contour in figure 4.5b can be divided into 4 sessions, C1, C2, C3, C4. The mapping of the 4 sessions in G of S H of S plane can be carried out session wise and then it should be combined together to get the entire G of S H of S contour. அப்போ ஃபர்ஸ்ட் எக்ஸாம்பிள் எடுத்துக்கிட்டீங்கன்னா 3 செஷனா இருக்கு. இந்த 3 செஷனையும் தனித்தனியா நம்ம என்ன பண்ணணும், மேப் பண்ணணும். ஃபர்ஸ்ட் C1, அடுத்து C2, C3, 4 செஷனா இருக்கு. இதுல C1, C2, C3, C4 இப்படி இருக்கு. அப்படின்னா 4 செஷனையும் தனித்தனியா you have to map and then you have to combine all the mappings. Okay, அது எப்படி பண்ற, how to map it session wise. You can see it in session C1, the value of omega varies from 0 to infinity. You can see it here, omega is varying from 0 to infinity. The mapping of session is obtained by letting S is equal to j omega and vary omega from 0 to infinity. இது எதுல பார்த்திருப்போம், போர்டேலையும் இதான் பண்ணிருப்போம். S is equal to j omega போட்டு 0 to infinity வரைக்கும் வெரி பண்ணி பார்ப்போம். போலார்லையும் இதான் பண்ணுவோம். We will do the same thing in polar. When you substitute S is equal to j omega, convert the transfer function into a sinusoidal transfer function, then you vary the omega from 0 to infinity. That is what we call it as a polar plot. We divide them into magnitude and phase equations, then substitute the omega value, plot it in a polar plot. Okay, but we can roughly say how the polar plot look like using the conditions available based on the type and order of the system. Okay, type and order of the system. Polar plot how do you normally do in a polar plot? Let us say if type is 1 and the order is 2. If type is 1 and the order is 2. How do you draw? How your polar plot will look like? Type is 1. So type 0 is here, type 1 is here, order is 2, this is first order, second order. So obviously it should be like this, the polar plot. This is omega is equal to 0 and this is omega, this is where it ends at omega is equal to infinity at this point. Okay, so that is how we go for the plot. That also is possible because Nyquist doesn't worry about the shape of the curve, it is worrying about only the encirclement around minus 1 plus 0 point. The shape எப்படி வேணா இருக்கலாம், அது கொஞ்சம் முன்ன பின்ன இருக்கலாம் கூட, but they are worrying only about what is the encirclement around minus 1 plus 0 point. அது மட்டும் தான் அது கவனமா இருக்குமே தவிர அந்த encirclement உடைய ஷேப் தேவையில்லை, டைரக்ஷன் தேவை. minus 1 plus 0 எத்தனை encirclements பண்ணிருக்குன்றத பார்க்கணும், டைரக்ஷனையும் பார்க்கணும். இதை பேஸ் பண்ணி தான் ஸ்டெபிலிட்டி சொல்ல முடியும். அந்த என்சர்க்மெண்டோட ஷேப் எப்படி இருந்தாலும் அதை பத்தி கவலை கிடையாது. அப்போ அது எப்படி மேப் பண்றது? You can go for a polar plot. This is first one. You can go for a polar plot, or you can draw a rough plot based on the knowledge of type and number of type and order, knowledge of type, number and order of the system. We can draw roughly the mapped points. Okay, so that is the second way. Mostly we will do this one. Sometimes we are supposed to follow this one. What is that? You divide that into two equal two parts, that is real and that is modulus of g of j omega, angle of g of j omega, and equate the phase to 180 degree and find what is omega. That omega is called as phase crossover frequency, and that is the point. And if you substitute that omega in the magnitude, that point will be the crossing point in the real axis in your S plane. The problem செய்யும்போது இன்னும் கூட கொஞ்சம் தெளிவா புரியும். Based on that, you can draw the approximately the locus using polar plot. Okay. Then இது C1க்கு, C1க்கும் அதேதான், C3க்கும் அதேதான், depending upon the contour எடுத்தது பொறுத்த வரைக்கும் 0 to infinity omega vary ஆகுது. இதுல C2 பொறுத்த வரைக்கும் how to go for it? We say here C2 is the radius is infinity. Therefore every point on session C2 has infinite magnitude, but the argument varies from minus pi by 2 to plus pi by 2. You can see that இது வந்து இது pi by 2 90 degree, இது என்னது minus pi by 2. So it is varying from pi by 2 to minus pi by 2. Hence the mapping can be obtained by setting S is equal to limit r tends to infinity r e power j theta. இத s க்கு பதிலா உங்க ட்ரான்ஸ்ஃபர் ஃபங்க்ஷன்ல போட்டுட்டு you can proceed by varying theta to pi by 2 to minus pi by 2. இப்போ அதுல பாத்தீங்கன்னா what assumption என்னன்னு பாத்தீங்கன்னா 1 plus st அப்படினா infinity r உடைய வேல்யூ இன்ஃபினிட்டியா இருக்கறதுனால 1 plus st, இந்த 1 வந்து it will not have a significant contribution, so you can convert this 1 plus st into st and you can substitute this, so you will get a value. Based on that we can map it. You will see if a C3 it's a replica, it's a mirror image of C1. இது 0 to infinity plus infinity போதா, இது minus infinity to 0 வருதா, அப்ப இங்க எப்படி இருந்ததோ அதோட mirror image தான் இதுல இருக்கும். So அது ஈஸியா அப்படியே mirror image ஆ கூட நீங்க வரையலாம். இப்போ இந்த பாயிண்ட பொறுத்த வரைக்கும் இஷ்யூ இல்ல. இப்போ இங்க வாங்க. let us say this C4 இதோட ரேடியஸ் என்னவா இருக்கும்னா 0. அப்போ செகண்ட்ல நீங்க C2 எப்படி ஒர்க் பண்ணீங்களோ மேப் பண்ணீங்களோ அதே மாதிரி தான் s is equal to limit r tends to 0 r equal to z ன்னு போடுவீங்க. ஓகே, அப்போ அசம்ப்ஷன் என்ன 1 plus st is equal to st வராது. அப்போ 1 plus st will be equal to 1. ஏன்னா ரேடியஸ் வந்து 0ங்கிறப்போ சிக்னிஃபிகன்ட் கான்ட்ரிபியூஷன் s-னால ப்ரொடியூஸ் பண்ண முடியாது. அப்போ மேக்ஸிமம் 1 தான் இருக்கும். அப்போ 1 plus st is equal to 1 ன்னு மாத்திட்டு நம்ம ஒர்க் பண்ணணும். Here, yes, 1 plus st can be converted into 1. So this is how they normally go for it. So based on the available diagram, what you finally got in g of s h of s plane, based on the encirclement around -1 plus j0 point, you can conclude and comment about the stability of the system. We will see a problem which will make you understand the concept in a better way and in a simple way in the next lecture.